Welcome to my channel. My name is Josh Christian, and today I want to talk about people's perception on what hacking is and how that vastly differs from what it's actually like. There's a miscommunication to the public about what hacking is really like, and I think Hollywood is mostly at fault for this misrepresentation. Hacking in movies and media is seen as this heroic, anti-government, anti-totalitarian movement performed by young people to get back at the system, or do something impossible and amazing for the sake of their future. Take movies like Swordfish, War Games, or any other of the hundreds of Hollywood hits with hackers in them. The hacker is always represented as the anti-hero of some sorts, and their abilities are unrealistic to the point that the average person doesn't even really know what hacking is anymore. And even documentaries about real events or people, like Snowden, WikiLeaks, and Julian Assange, are highly exaggerated and romanticized to the point that they're like Greek gods. They probably were real people at some point, but over time, the tales morphed into these unrealistic, fictitious stories of entertainment. So what actually is hacking, and how does that compare to what we think about as hacking, rather than the actual act of doing it? I think it's really important for somebody that's new to cybersecurity to have a realistic perspective of how it actually works, and what the basic fundamental process of hacking something really comes down to. To start with, we're actually using the term hacking incorrectly. In computer science, hacking historically just meant creating a file. Cracking, on the other hand, is the correct term, which means breaking into something illegally. However, languages change, and I'm not the vocabulary police, so whenever I say hacking in this video, I really just mean cracking in the traditional meaning of the word. Breaking into something that isn't yours and you shouldn't be allowed access to. Generally, in Western media, the act of hacking happens within seconds. A young bright kid pulls open his bulky laptop in his parents' basement and starts furiously typing away, trying to break into a website within seconds for whatever the purpose in the movie's storyline is. Movies are short and don't have a lot of time, I understand that, but it makes people think that hacking is some sort of chess game where the smarter person can magically and instantaneously break into any website on sheer knowledge or genius alone. But of course that's entirely unrealistic and absolutely nothing what real hacking looks like. The majority of convicted hackers are people with master's degrees or PhDs in computer science, IT infrastructure, and cybersecurity. Most of them are beyond their 40s and generally well into their 50s, and even if they don't have formal education, they generally have decades of work experience in the field. Assuming somebody is knowledgeable enough about computer science, the Internet of Things, servers, programming, and the frameworks related to the back end of the websites they're looking to hack, the actual process of hacking a website could take weeks or more. You don't just hop onto a website and type in some fast code and brute force your way through their security. Not usually, at least, unless it's a small website that has zero security and you already know in advance exactly how to get in. Hacking is somewhat like solving a massive jigsaw puzzle or competing in a complex scavenger hunt. You're going through a list of hundreds or even thousands of possible backdoors, errors, and oversights in the architecture of a website or server. It could take you weeks, and in many cases, months of trial and error, searching for a mistake that their engineers could have made. Especially in today's day and age with banks and websites hiring hundreds of professional security engineers with decades of experience. To hack into something like Facebook, you would have to effectively find an error or gap in their security that their 1,000 plus security experts missed. Not an easy task, if it's even possible at all, aside from sheer luck. Hacking comes in many forms, and it's not as simple as writing code and magically unlocking another person's computer over the web. There are physical brute force attacks that require you to be at that person's machine, as well as attacks where an intersection occurs between Wi-Fi router signals. There are also luring attacks called watering holes to get people to connect to free Wi-Fi disguised as public access points, and even attacks where you pre-install a keylogger or some sort of malicious software onto the person's computer. And of course, we all know about phishing schemes, where an individual poses as a legitimate website with a slightly different URL to trick you into giving them your username and password. With such a huge variety of types and styles of cybercrimes, the label hacker has actually become quite broad. From the people making viruses and malware, to the SQL injectors, you can classify most of these characters as hackers. The semantics of what characterizes a hack are somewhat obscure, Some even consider people who send unwanted spam emails as hackers, though I personally would not. The term hacker is an English word that will probably continue to evolve with time, so I don't get caught up in the semantics of the word too much. It will mean whatever culture and society chooses for it to mean at any given time. There are thousands of different techniques, methods, and approaches when it comes to hacking, so I can't show all of them off in this video, but I will show a few real-life examples of hacks that people have used to break into or shut down various websites or networks over the past few decades. That way you get a glimpse of how it actually works. A DDoS attack, or distributed denial of service, is one of the most common attacks you hear about on the news or in the media. It's actually a relatively simple principle. The goal is to shut a website down so it cannot operate or provide services to clients. Generally, this type of attack is used by terrorist organizations, governments, secret groups, or social engineering programs to take down a website they disagree with, usually to send a message. The way this is done can vary in some regards, but the general idea is to overload network servers by requesting a load that exceeds the network's limits. Every time you load a web page, a server somewhere is pushing the data to your computer, and if too many computers request data at once, it bottlenecks the system, causing it to cease operations, or in some cases, to crash entirely. This is a very simple attack to understand, but almost impossible to prevent entirely if you're a network administrator or cybersecurity expert trying to protect your company's web front. The hacker can use one powerful machine from one IP, or split it into multiple IPs coming from any location around the world. But more commonly, large companies and governments may use servers or powerful machines all around the world in the hundreds of thousands to attack a website. And that can make it effectively impossible to navigate what machines are real consumers and what's just an attack node. There are variations of the DDoS, such as NTDS, STDS, and ATDS attacks, all of which operate in a similar fashion, but they attack different areas of the system, like the network or application interface. There are a plethora of ways companies try to divert and mitigate network load per user to help fight against DDoS attacks, and many of them are highly effective, especially as AI detection of false nodes and users becomes more powerful. But as of right now, there is no guaranteed way to stop them entirely. As an example of that, in the last few years, the Pentagon, Amazon, Blizzard, Yahoo, GitHub, and even Google have all been affected by large-scale DDoS-style attacks. And sometimes these attacks can knock a network out for hours at a time, costing companies millions of dollars in lost revenue. A SQL injection attack is one of the most terrifying and nefarious hacks that exists, because its sole goal is to steal private user data. This could be data such as credit card numbers, social security numbers, usernames, passwords, or any other number of private user data stored on a given website. One of the main dangers of SQL injection attacks is that it can sometimes happen without security ever even realizing anything went wrong. In case you didn't know, SQL or SQL is a domain-specific language designed for managing data on servers, and in some cases, if specific precautions are not accounted for, a user can actually use SQL to talk to the servers from the website's normal interactive input parameters. When you log into Facebook, you enter your username and password, and those fields could potentially be filled with SQL code that will actually trick the system into thinking you are the internal network requesting data. You could use this method to potentially unlock somebody's account or steal private secured information to be used for illegal activities. Fortunately, there are a huge amount of security checks you can do to prevent this from ever happening on your website or network. But even to this day, not every method has been discovered yet, and sometimes you hear about SQL injections happening on smaller websites or storefronts that aren't well prepared for such attacks. As a security expert, you'd need to build a lot of guards into the system to prevent SQL injections coming from an outside source. Though sometimes these experts miss some guards or just don't know about them yet, and then you get hackers trying every known method in the book to find the site's weakness until something works. Other notable attacks that are commonly used are MITM, also known as man-in-the-middle attacks, where a system interjects itself in between the server and client, all while fooling the client into thinking it's still networking with the host. This method can intercept any information sent back and forth and use that data for whatever illicit activities are sought after. Generally, hackers use this to steal bank transactional data or other information like credit card numbers and passwords. Cross-site scripting, or XSS attacks, are also used commonly where possible. This is similar to a SQL injection, but instead of targeting the website, you're actually targeting the users on the website. This is usually done with links that contain JavaScript code that runs in the browser. Sometimes, hackers will inject this code into a comment or a link on a web page where user input is allowed. It's also commonly passed through unverified plugins on your web browser. This is actually part of the reason why YouTube disallows links or anything resembling code in the comments. We are all familiar with malware, and while the concept of malware or viruses is very simple, the actual design varies so widely and can be so complex that even the best antivirus programs and designers in the world can't detect it. Because malware is usually installed onto the computer in the form of an executable or hidden file infector, it can actually fuse itself with the operating system's boot record in ways that make it impossible to remove unless you do a full system wipe and reinstall. Keylogging malware is especially dangerous because it can steal all of your data without you ever even knowing you were infected. The worst viruses are actually the ones you cannot detect. There's also a growing number of viruses infecting computers using stealth measures so they can mine Bitcoin and cryptocurrencies on thousands of computers at once to exploit mass hardware resources for financial gain. Though this kind of attack is less harmful than many, it can prematurely damage your hardware components and slow down your machine during use. In many ways, we're all vulnerable to thousands of potential hacks in the same way that we're all vulnerable to dying in a car crash or being shot in the street. It's not likely that it will happen, but it's still best practice to take precautions to limit your exposure to dangerous situations as much as possible. Thanks for watching this video. I really hope you learned something about what hacking is actually like and can better appreciate just how hard it can be and why it's so important that we protect our electronic signature by making smarter decisions about our personal cybersecurity. Please like and subscribe to my channel for more content coming soon, and share this video with your friends who claim they can hack Facebook in their sleep. I'll see you on the next one.